let's just see what is the fundamental theorem of arithmetic. The fundamental theorem of arithmetic says that every composite number can be expressed or factorized as a product of primes, and this factorization is always unique apart from the order in which the prime factors occur. So let us suppose we are talking about the example which we have done earlier of getting the factors of 1178. So we expressed the 1178 number as a product of primes. So it means that the composite number 1178 can be expressed as a product of the primes, and that primes are actually unique apart from the order in which the prime factors occur. Means the order of the primes doesn't matter, we can write the primes at any particular position, but yes, their uniqueness do have an important role in the fundamental theorem of arithmetic. So fundamental theorem of arithmetic says that every composite number can be expressed or can be factorized as a product of the primes, and this factorization is definitely unique. So this portion is actually very important, that this factorization is always unique. They do have a unique prime numbers in their factorization, but their order doesn't matter, we can write their orders in any particular way. So from the order in which the prime factors occur, it doesn't matter at all, but their uniqueness plays an important role. So let's just move on further and talk about the fundamental theorem of arithmetics, theorem number 1, which says that let P be a prime number and A be a positive integer. So let us suppose we are talking about the theorem which says let P be a prime number and A be a positive integer. So if P divides A square, then P divides A. So we have to prove that if a prime P divides the square of a positive integer, then it should divide the number A itself. So let's just start the solution set of this particular question or this particular theorem. So basically we are proving the theorem. So let's just start proving this theorem. So what is the proof of this theorem? What is the proof of this theorem? So let us suppose we are taking A be a positive integer. So by the fundamental theorem of arithmetic, we know that every composite number can be expressed uniquely as a product of the primes. It means that by fundamental theorem of arithmetic, A can be expressed as a product of the prime. So let us suppose let A is nothing but is equal to P1 into P2 into P3 into P4, so goes on into Pn. Let us suppose I'm talking about expressing the A number as a product of the primes P1, P2, P3, P4 and so goes on Pn, where Pi's are prime numbers, not necessarily distinct. So here we are expressing the number A as a product of the prime numbers. Let us suppose we are taking P1, P2, P3 and so goes on, and we are saying that let us suppose these Pi's are prime, but they are not necessarily distinct. We cannot say these are distinct, because we have seen in the question while finding out the factors of the number 1178 that 2 definitely repeats itself many a times. So here we are taking A as P1, P2, P and so goes on, where the prime numbers are not necessarily distinct. So let us suppose we are talking about taking the square of this particular equation. So let us suppose I'm taking the square. Let us suppose I am taking square of equation number 1. So if I'll take a square of the equation number 1, it means that I'm taking a square of this number and I'm taking a square of P1, P2, P3, P4 and so goes on Pn. So let us suppose I'm writing it as P1 into P2 into P3, so goes on Pn. The square of these numbers will definitely means multiplying them twice, which is nothing but is equal to of the type P1 square, P2 square, p3 square, and so goes on. Let us suppose pn square. So at the end we are getting the result as a square is nothing but p1 square, p2 square, p3 square, so goes on pn square. So let us suppose I am calling this equation as equation number 2. So according to the question, what is given to us? According to the question, ATQ means according to the question, it is given to us that P divides A square. According to the question, it is already given to us that P divides A square. So if P divides A square, it means that P is nothing but a factor of A square, because we know that A square do have the prime factors as P1 square, P2 square, P3 square, so goes on Pn square, which are nothing but of the kind P1, P2, P3 and so goes on Pn. So it means that if P divides A square, P is a factor of A square. So by the uniqueness part of the fundamental theorem of arithmetic, we know that if P is a factor of A square, then definitely P is nothing but a factor of A. If P is a factor of A square, it means that P should be among all these numbers, and these numbers are nothing but the power of the same primes. Means P1 is multiplying with P1, means a number is getting a square of itself. So basically we are talking about if P is a factor of A square, then P should be among, P must be among P1, P2, P3 and so goes on Pn. It implies that P definitely divides A. Why? What is the reason? Since we know that A is nothing but a product of P1, P2, P3, so goes on Pn. So at the end we get the result as if P divides A square, then P divides A. So if any prime P divides the square of the number, then that prime P definitely divides A. So this is nothing but the proof of this particular theorem. Hence prove that for any prime number P, if A is a positive integer and if P is dividing the square of that number, then definitely the P should divide that particular number itself. So this theorem we have proved with the help of the fundamental theorem of the arithmetic. So let's just move on further toward the another concept.